This video in the PM1 course is the second on geometric series and looks at the sum of a geometric series. In the last video we looked at geometric sequences such as 3, 6, 12, 24, 48, where the next term of the sequence is achieved by multiplying the previous term by 2 in this case, or by a common ratio, the same number. In this video we're going to look at finding a formula for the sum. So we want to know the sum of the sequence, and the sum of a sequence is known as a series. So this is a sequence, this is a series, as we said. Now this series can be written like this. 3 is the first term, the next term is 3 times 2, the next term is 3 times 2 times 2, which is 12, or 3 times 2 squared. The next one is 3 times 2 cubed, 3 times 8, 2 cubed, and then 48 is 3 times 16, or 2 to the power of 4. And we can see the pattern in the terms here, and as in the previous video on the geometric sequence, we know that if we have a geometric sequence where first term is a and common ratio is r, then we can write it ar squared, ar cubed, etc. And the general term is ar to the n minus 1. If you remember, the number of the term is always 1 more than the number in the power. Here, 3 times 2 to the 4, that's the fifth term, and 4 is 1 less than 5. So we need to find the sum of this general series a plus ar squared plus ar cubed, and so on up to ar to the n minus 1. That is the general geometric series. We add them up, add up the terms of the sequence, we get the series where the first term is a and the common ratio is r. Now this is a proof that you will need to learn because it might be asked for in the exam, and we do it in this way. Let's call this S. The sum is equal to, the sum of the series is S. Well, what I'm going to do is I'm going to multiply S by R, so to make RS, and therefore that is equal to this series multiplied by R. So first term A multiplied by R is AR, and I'll write it here. And the second term AR is multiplied by R is AR squared, I'll write it here. The third term AR squared times R is AR cubed. Then we have AR to the power of 4, and we carry on. Eventually we'll find a term AR to the n minus 2 multiplied by R will give us AR to the n minus 1, and then AR to the n minus 1 multiplied by R will be AR to the n. So we've just taken the series and multiplied it by R. And now what I'm going to do is subtract the two, the RS from S. So S, take away RS, equals the first series, take away the second series. Well, we have A, then we have AR, take away AR, well that's nothing. AR squared, take away R squared, AR cubed, take away R cubed, and all the terms are going to cancel up until AR to the n minus 1, and then we'll be left with minus AR to the n. So we see S minus RS is just A minus AR to the n. We can factorize. This is 1 minus RS, and A minus AR to the n, we can take out a factor of A, 1 minus R to the n, And then if we divide both sides by 1 minus r, we find that s equals a 1 minus r to the n divided by 1 minus r. And that is a formula for the first or the n terms of the general geometric series. So that's one that you need to know. Now I could have subtracted s from rs in these series here, in which case I would have got s equals a r to the n minus 1 over r minus 1. In fact, you can achieve that just by multiplying top and bottom of the series here in the red box by minus 1. They're the same thing. You either put the r to the n first, minus 1, and r minus 1, or you put 1 minus r to the n. Basically, if r is less than 1, then the first formula might be neater because you'll have positive on the top and positive on the bottom, or if r is greater than 1, the second one, where you'll have positive numbers on the top and bottom. But in either way they'll both work. Now, 3 examples now. Simple one here. Find the sum of the first 8 terms of the series that I first wrote down, 3 plus 6 plus 12 plus 24, and so on. Well, this is a series where the first term a is 3, and we can see that we're multiplying every term by 2 to get the next term, so r is 2. So since r is greater than 1, I suggest using this second series, this one in the orange box, this formula, as it makes the top and bottom both positive. So s equals a r to the n minus 1 over r minus 1. N is 8. We want 8 terms. So the sum of 8 terms is a, which is 3, r, which is 2 to the power of 8 minus 1 over 2 minus 1. And this equals 3 times 256 minus 1 over 1, which is 3 times 250, which is 765. Okay, second example. The sum of the geometric series 2 plus 6 plus 18 plus 54, and so on, exceeds 5,000. Find the least number of terms. So we're adding up all these terms of the series, and we know that the total sum is more than 5,000. What is the least number of terms where that is true? Well, this series has first term a is 2. The common ratio r is 3. 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. We want to know, we know that s is greater than, the sum is greater than 5,000. What value of n, what is the smallest value of n for which that is true? Well, again, we want to use the formula a r to the n minus 1 over r minus 1, giving us positive on the top and bottom of the fraction. So s is 2, 3 to the power of n minus 1 over 3 minus 1. Well, 3 minus 1 is 2, so that's 2 divided by 2 times 3 to the n minus 1, so the 2's cancel. And s is greater than 5,000, so 3 to the n minus 1 is greater than 5,000. And therefore 3 to the n is greater than 5,001. Now, just like in the previous video where we had inequalities where the unknown, the n, is in the power, the index, we need to use logarithms. If 3 to the n is greater than 5,001, so the logarithm of 3 to the n is greater than the logarithm of 5,001, because as you remember, logarithm is an increasing function. If that is greater than that, then the log of that is greater than the log of that. So the log 3 to the n is greater than log of 5001. It's true for any base. Well, let's take base 10 here. And using the log law that enables you to write the power multiplying the logarithm, we get n log 3 is greater than log 5001. And then dividing by log 3. Now remember, as I said in the last video, log 3, is it positive or negative? Log 3 is positive because 3 is greater than 1. If it was log of a half or a number less than 1, that would be a negative number and you'd have to reverse the inequality symbol. But log 3 is positive, so we don't need to reverse the inequality symbol. So log 5001 over log 3. So on the calculator, if we do that, we find n is greater than 7.753 to 3 decimal places. N is a whole number, so n equals 8. So 8 terms is the least number for which the sum is greater than 5,000. Okay, the third example is what we call a real life problem. Now we have one of these when we were doing the sum of the arithmetic series in the previous video. This one here we have, let's read it. Nathan invests £500 at a fixed rate of interest of 4.5% per annum. Per annum means every year. He invests a further £500 on each yearly anniversary of the first deposit. So he's putting in £500 every year, but of course the savings accumulate interest as well. So the savings increase by two ways: further deposits and interest. Assuming no withdrawals are made, so he's not taking any money out, calculate the balance in the savings account at the end of the 8th year. So how much does he have at the end of the 8th year? Now, with this sort of question, it's a good idea to write down how much or what's going on at the key points in the timeline. So at the beginning, what happens at the end of each year when we have interest, at the beginning of the next year when we have a deposit. So we write down what's happening, and then we should be able to see a pattern. So start of the first year, he invests £500, so we have 500. At the end of the first year, we're adding 4.5% interest, so that's 500 plus 4.5 over 100 of 500. That's 4.5%. Well, I could write that as, if I were to factorize it, 500 times 1 plus, and it will be 0.045 or 1.045. Let's go to the start of the second year. Start where Nathan deposits another £500. So we have 500 times 1.045 from the end of the first year plus 500. Well, I think I'm going to write that around the other way and make it 500 plus 500 times 1.045. Then we go to the end of the second year, where we're going to add another 4.5% interest. So that would be 500 plus 500 times 1.4045. and then 4.5% of that. So that will be plus 500 plus 500 times 1.045 times 4.5 over 100, or 0.045. Now we can factorize that, because we have 1 of this 500 plus 500 times 1.045, and then 0.45 times that. So in fact that comes to 500 plus 500 times 1.045 times 1.045. And in fact, just by adding 4.5% onto something means onto amount it's the same as multiplying by 1.045. Now we go to the start of the third year, when we're depositing another 500. So that gives us 500 plus what we already have. Now what do we have? Well, we have 500, if we multiply up this bracket, 500 times 1.045 plus 500 times 1.045 squared. At the end of the third year, we're going to add another 4.5%, which means multiplying everything we have at the start by 1.045. So let's just do that, multiplying each term by 1.045. So the second term will have squared, and the third term here will have cubed. End of the third year. Now we go to the start of the fourth year, and we're going to add another 500. So another 500 at the beginning, plus all the rest of the terms that we already have. So maybe we can see a pattern now. 500 plus 500 times 1.045 plus 500 plus times 1.045 squared, etc. And that is at the end of the start of the fourth year. So we could have a formula for the amount at the start of the nth year, after n years. Well, it's 500 plus 500 times 1.045 plus 500 times 1.045 squared, and it continues until, well, when it was 4, it up to cubed, so it would be 500 times 1.045 to the n minus 1. Now that's the start of the nth year. We want the end of the 8th year. So at the end we can do a general formula. End of the nth year, well, we're going to add another 4.5%. So we're going to multiply this by 1.045. So that would be 500 times 1.045 plus 500 times 1.045 squared, plus until we get 500 times 1.045 and to the n minus 1 times 1.045 gives you 500 times 1.045 to the n. Now this is a geometric progression, a geometric series. We are just multiplying each term by 1.045. We want the end of the 8th year, so let's put down first term A. Well, that's 500 times 1.045. How many terms? Well, we've got 8, n is 8, and R, the common ratio, is 1.045. And the sum of a geometric series, A r to the n minus 1 over r minus 1. substituting the values, 500 times 1.045, 1.045 minus 1, 1.045 to the 8 minus 1, I should say, over 1.045 minus 1. And if we calculate that, we get 4,901 pounds and 6p to the nearest penny. Okay, that's the end of this video on the sum of a geometric series. Now return to Study Smart, where in fact you'll find a third video on geometric series, which is about the sum to infinity of a geometric series.